Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll try to get to as many questions as we can near the end of today's webinar. And then finally, also at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards, which I know will come in very handy for the holidays. So please stick around and hopefully you'll be one of our 3 lucky winners. Okay, with that, we will kick off today's webinar, which is 5 ways to quick start a digital transformation project. A topic that is near and dear to many hearts, I'm sure. So let's introduce today's speakers, who are, first of all, we have Marty Bakal, who is Product Marketing Director at OpenLegacy, and Zeev Avidan, who is Chief Product Officer at OpenLegacy. And later on during the webinar, they're going to be joined by George Morlett, who is Enterprise Architect. He'll be doing a quick demo. Welcome, gentlemen. Thank you so much for joining me today. Marty, I know that you have a great webinar on tap, so and a great presentation. So let's get right into it. I'm going to put myself on mute and let you get started.
Okay, thank you very much. So the agenda today is rethinking digital transformation, and then we're going to talk about steps to incorporate your on-premise systems and how those actually work. Some people call them core systems. And then we're going to talk about test and development strategies. And we're going to have some real-life samples, demo-driven transformation. And then we're going to have actually a demo, which she already mentioned George is going to do, and questions and answers. The way this is actually going to work is Zeev and I are actually going to flip slide pretty frequently, so you can hear both of our voices coming back and forth. But I think it actually makes it for a little more interactive in that sense. So that's how it's going to work. But the first question, whenever we think about digital transformation, is how do we really start it? I mean, if I give my son a bunch of Legos like this, whole pile, he doesn't always know where to start. He usually starts by taking a small section, starts building them up and doing some different steps from there and going. And in many ways, that's what we like to think of ourselves when we're doing this, right? With OpenLegacy, you can start off at an easy pace and then keep growing as you go. And so that's a very important thing to think of whenever you want to think of like trying to start with DevOps, start with digital transformations, and take all the steps that you want to go. So now I'm going to hand it over to Zeev, and Zeev's going to talk about some examples around that.
Yeah, sure. Thanks, Marty. So when starting with digital transformation, I mean, the term itself is a bit daunting. When we talk about digital transformation, usually for large enterprises, we're talking about huge projects, multi-year projects, and we're thinking about overhauling entire systems and migrating from systems. But the point is, it doesn't have to be that way. You can start a digital transformation project very small and grow from it, and you can get results pretty quickly, so you don't have to wait a long time until you see results. Just to give you a couple of examples, and these are real-life examples just to kind of level set in terms of what we're talking about here. A couple of examples are an insurance company, for example, that was able to create 100 APIs in a little over 2 months. And basically that saved them development time of around a full year. And creating 100 APIs in 2 months, that's a game changer in terms of their ability to basically serve the business. Another example would be a bank that was able to deploy 27 APIs underlying that or 70 microservices in about 10 weeks, or creating an API in less than an hour, meaning the marginal API that gets created very, very fast. These types of results really demonstrate the fact that the digital transformation is not necessarily this kind of a huge product with a huge product roadmap, or a project roadmap, sorry, but rather a continuous process that if you do it right, you're able to increase the value as you go along. The challenge is that if you talk about large enterprises, you usually talk about legacy systems and core systems that are on-prem, that might be, a little bit slower. So you might say to yourself, well, all these new technologies are great. They can really help me move fast, containerizations and APIs and microservices and all of those things. But what do I do with my, mainframe? What do I do with my S400? What do I do with my SAP on-prem Oracle application? Even old SOAP services. What do I do with all of those? How do I incorporate them into my digital transformation? Do I absolutely have to migrate away from my legacy systems in order to get to those results? Well, the good news is that you actually don't. And we will describe to you a couple of, very easy steps for you to incorporate a legacy system or legacy functionalities and applications into a modern digital transformation process, and doing it in a way that brings you all the value and all of those, the speed and agility, but without doing a full-on migration. And I'll hand it over to Marty. Marty, we can hear you.
Oh yeah, sorry about that. I muted myself for all that, and then I forgot to actually unmute myself. With these steps that we're talking about here are actually steps that we take, but they're actually steps that you can do in different orders. You can do different things like that, and some people have certain blockers that are very specific about certain things. So, but the first one we're going to talk about is getting started with limited resources. Why are legacy team members normally required? Why do you have to include legacy team members to actually do the type of stuff he just talked about with digital transformation? Usually to analyze the actual data, take a look at the data type translation and actually translate from a legacy data type to, let's say, a Java data type, and for building facades that actually do that translation on the legacy system. Those are the reasons why, but if you didn't need them, it would actually be very helpful. And so I'm going to hand over to Zeev to discuss how you wouldn't have to need them.
Sure. So, I mean, when you're dealing with legacy systems, of course, legacy systems have their own ways of doing their own processes, their own ways of doing things. They, have worked in the past and are continuously working. And this is why they're legacy systems, because they're stable and they give you the results that you need. They're not necessarily the best fit for what you're trying to do. So there might be two approaches there. One approach would be to try to change the processes on your legacy side. And there are some, companies and products and great offerings around that. But separate from that, you can have a different approach, which is basically abstracting the access between the two things. One of the big challenges around incorporating a legacy system into a modern development process is the fact that you have to go through, these middlewares, and you have to go to these processes that are very coupled, very monolithic, and that really kind of goes against the grain of what you're trying to do. Because if you think about development as a chain, and that chain, have different links, and each link takes a certain amount of time. If one link takes you, a day, and the other link takes you a month, then the overall chain takes you a month and a day, and you can't get around that. And if you're talking about specifically legacy systems, if integrating and getting into the data on the legacy side, if going through all of that middleware and propagating the service throughout the middleware, if that takes you a long time, nobody cares about the fact that you're doing things on the digital side, you're doing it very, very quickly. So the key here is basically abstracting the legacy side from the digital side. And what you gain by that is basically, first of all, the flexibility for your digital side to pick and choose which resources they want on the legacy side. All of those resources are available to them. You don't need to go through multiple iterations where you need to go and start the process again, and having the legacy side people change facade programs and propagate changes and doing things like that. But rather, you just provide kind of a catalog of services that are available for the digital side people to just pick and choose what they want to use. And specifically, OpenLegacy does that by automatically creating that catalog of services in Java. So you have Java components that are available and you can use them. But at the end of the day, the overall concept here is basically abstracting the access to the legacy and providing it in a way that's easily consumable by the digital side, so you don't have to do these long iterations, but you can work in short circles. If you do that, basically what you eliminate, of course, you don't eliminate the need for legacy, and you don't eliminate the need for legacy skilled people to do their thing. But what you do eliminate is the turnovers and the interactions between the two teams, which are always time consuming and takes a lot of coordination. And also you can eliminate the middleware, which is where a lot of the time also gets lost, and you need specific skills and you need specific processes. So that's that with regard to how do you deal with limited resources, specifically with legacy resources. But how do you get started? What does an MVP look like? I'll move it over to Marty.
So, I mean, thank you very much. And I think when we talk about start with an MVP, everyone always talks about minimal viable products, and these MVPs are sort of ideal. Usually that's hard to do in this type of situation. The reason why is because you have to parse the whole monolith, you think, to actually figure out the information, to understand it, and it's hard to identify something up front. So we really talk about picking a pain point for an organization that's impactful to stakeholders and is easily definable, and then using automatic parsing, which is one thing that OpenLegacy does, to actually parse the monolith and pick only the stuff you need to work on to build that MVP, which usually is just very difficult because of the nature of a monolith, because it's much easier with automatic parsing. That simplifies the integration scenario, allows teams to get started. Now, talking about a customer, Ayalon Insurance in Israel, they had a goal of where IT was not going to be the bottleneck anymore. And they wanted to try an MVP, which was a new deal with a large bank they were working with, where they're going to sell to the corporate customers. Well, not only was IT not the bottleneck, IT actually got their work done 2 months before the final agreement was signed, since it takes a while to sign with a large bank, with the insurance company, working everything out, how it's going to look. So really the solution was DevOps, because they felt DevOps was critical to what they wanted to do, and legacy integration, because they're using an AS400 machine that they had to have legacy work on. So for that, to talk a little more about what they actually did and what their whole process was, I'm going to hand it back to Zeev.
Sure. So basically, I mean, the Alon example, what they were looking forward to is getting their processes very, very quickly. They understood that the major problem that they encountered is that by the time they deploy a service into production, it's already obsolete. And the example that Marty talked about, basically, they had this engagement with the bank. They wanted to sell insurance to the bank's customer, and they were able to deliver the APIs 2 months ahead of the commercial agreement, which really everybody took notice of that. And that's one of the benefits of having an MVP. If you have an MVP, a specific project, and it's important to have that MVP as something that has business value, something that will resonate within the organization. If you have this kind of an MVP, you can start small, but still you're making an impact. And that makes everybody take a notice and look at it and say, wow, this is something new, this is something successful, and really invest more in that in terms of mind share and in terms of the willingness of other departments in an organization to participate. Nothing is more successful than success, and showing success at a small scale and scaling it up, that's usually a way to go. Specifically for what they've done is they were able to create this entire DevOps pipeline and process, starting all the way from Jira as a requirement management, and all the way to deployment through Docker, Kubernetes. And really the linchpin of that was using the OpenLegacy platform as a way to get the AS400, in their case, it can be a mainframe, it can be any kind of legacy system, get those assets as assets that are consumable in this kind of a process. So if you are able to expose services from a legacy system as Java components in this case, then you're able to use, or Java source code rather, then you're able to use Git and then Bitbucket and then deploy as just normal standard microservices to the Docker container system and basically orchestrate that with Kubernetes. This is an entire pipeline that has all the way from requirements to deployment in an automated way, which of course lends itself to DevOps concepts like testing and automatic moving between the different stages. From unit testing all the way to production. But basically, they were able to do that at a smaller scale using automation servers and things like that. So for that specific project, but then when they saw success, that's where they were able to grow it and create more and more services based on that process. But when you're doing that, there are some concepts that you need to take into consideration when you're creating these kinds of pipelines, specifically when talking with legacy systems and the integrations and connections that you need to do with them. And I'll move it over to Marty.
Yeah, and one thing I want to mention as I get into this is not only was it amazing how quickly they got it done, but also they had to use less resources. I mean, they were done 2 months before, which meant they could work on other things, those same developers. So there's a bunch of different things that were going on. So it took a smaller team quicker time to do it. So there's a lot of cost saving there as well. But right now we're talking about building connections to legacy systems quickly and easily. And again, if you do it quickly and easily, you save time, resources, everything. Generally, the way we think of this is it's usually very daunting to design an API, build a facade for on the legacy system, streamline communications, retrofit deployment environments, build on proprietary processes and things actually working with, and all those other parts. We really make this a lot easier because if you can make it automated, it becomes much easier. You can just expose the APIs, you can generate the connecting code, and you can use direct connections to even get a faster connection you would have gotten otherwise. We think of this as start with a legacy system over here and use a fetcher to actually pull the information into the IDE, which then parses that information, and then we can actually generate the microservices, or by the way, we could even generate serverless Node.js information if you prefer that, and then deploy it directly into a cloud or on-prem system very easily, and then actually then use it where it connects directly to the legacy system. So that's a whole process that really makes it very easy for you to do it and streamline that whole process and make it a lot faster. Now I'm going to hand over to Zeev to talk about automatic test generation, which is another key part of this whole process.
Sure, and just automatically generating or creating those services in a way that's DevOps, meaning code generation, and you can promote those assets and things like that. I mean, that's a great help. I mean, that saves you a lot of time. But what we found a lot of organizations saying, well, you know, that part is time consuming, and we get that. But the thing that really gets us, I mean, the thing that really is time consuming for us is the testing part. Because that's where, you know, a lot of organizations are still used to the old way of thinking. You know, back in the days, you deploy to production twice a year or something like that. Of course, not a lot of organizations are still there, but consider the fact that somebody like Facebook, they would deploy to production 10,000 times a day, and they would deploy to production without even, you know, testability is not even the main thing. It's about recoverability. So if something breaks, they can, you know, recover it very quickly. Now, I'm not suggesting that a financial service organization would rely on recoverability rather than, you know, rigorous testing. Of course, there's a lot at stake more than just, you know, your recent post or like. But even so, deploying to production, you know, a couple of times a year, of course, that's not an option. But even, you know, a few times a month is not really an option if you want to really move fast. And there's no reason for you to do that. If you're able to really break up the work and you're able to move towards a test-driven design, then testing can be automated so that it does support the process of continuous delivering and continuous integration. And continuous delivering, that really is a lot about testing. So continuous testing, as it were, really is the key of moving fast, because you always want to be sure that you're deploying something that is tested, and you want to be sure that that test is automatic and that you're not missing a step. So automatic testing really is dependent on two things. It's dependent on how well you're able to break up your development cycle, so you are able to do test-driven design. And test-driven design is basically the idea of every step you go, you finish that step of development by testing and being certain that everything is working up until that point. And it's also about having the ecosystem tools, ability to automate those kind of testing facilities and really use them in a way that's, you know, kind of part of the standard ecosystem, versus, for example, having specific proprietary solutions or technologies that don't allow you to have testing that participate in those kinds of tools. So just to give you an example, traditional integration stacks, ESBs, for example, they are notorious for not being easy to, you know, to test, because there's a lot of different, you know, moving parts. Things are moving in flows that are not necessarily very transparent and open, a lot of black boxes and a lot of proprietary technologies. And also just the fact that these are, you know, different teams and different platforms, and every team thinks, you know, maybe the problem is somewhere else. If you're able to break that in a way that, first of all, simplifies the stack, second of all, move it to a standard technology like Java using JUnit testing modules, and also break it up in a way that you can test every single part of it independently, that goes a long way into alleviating that pain. So, for example, in our case, and what we do, basically we automatically generate Java code, and that Java code separates the actual integration stack component to a specific functionality on a legacy side to a Java component we call an SDK. That SDK is basically, it's a POJO, plain old Java object that can be tested in a JUnit model that's, again, automatically generated alongside the POJO. And that POJO can be tested independently, so you know that access to that specific piece of functionality on the legacy side works. You're absolutely sure of that because you saw the testing, and it's done automatic. Now you can leverage that piece of functionality, that building block, in a larger service. You can test that service independently inside any kind of a Java testing facility, so the IDE, an Eclipse-based IDE, or whatever. And then at the end of that, the service itself as a contract. The contract might be, for example, RESTful API. You can test the RESTful API using something like Postman or some kind of other API testing tool. So you have different levels of being able to test. There's no real integration test that needs to be done, because these are microservices and they are independent from each other, because you didn't have to make changes on the legacy side. There's no testing that needed there, and the containerization enables you to separate things in a way that you're only testing the things that are in fact changing. And of course, automatic deployment after your testing can be just part of the pipeline. So doing it this way, co-generating specific components that talk with specific functionalities that are containerized, that are separate from everything else, that really helps, I don't want to say solve, but really goes a long way into really improving your outlook on big challenges like testing, which is always one of the most time-consuming part of the process. And since we've touched on the subject of deployment, I'll move it to Marty to talk a little bit about how you deploy that automatically.
Well, thank you very much. And I mean, deployment is another key point that a lot of people sort of forget. They're always like, wait a minute, I have to actually deploy this thing. And particularly with legacy systems, I think it's very daunting to try to do that other places, right? We really try to simplify deployment. Because we have microservices architecture and a direct connection to the legacy system, it becomes easy. You just put it in a container like with Docker, and then you can just deploy it wherever you want to. It's a much more simplified process. And so some people say, I love this quote, particularly the second one here, the senior architect. Architects have grown accustomed to thinking that robustness equals complexity. We prove that it's the other, that OpenLegacy demonstrates the other way is true. That's a very key thing to think about. Most inventions we get, a lot of different things that we actually talk about, actually are simple. And because a new concept comes in that simplifies things down to what they did before. And Credit Corp said, simplified our architecture to deploy faster and more efficiently. It's just, deployment can be easy if you follow the right steps and make it work right. And a lot of people actually understand that when they're dealing with, that's why microservices have become popular. That's why even the serverless just functions have become popular, because they're easy to deploy, put them out there, and then let them connect to the right thing, rather than having all this middleware and everything else that muddies up the water as part of that. So now I'm going to hand it back over to Zeev, and Zeev's going to talk about how the process actually works.
So thanks, Marty. So, I mean, let's tie it all together. I mean, we've talked about a bunch of things here, but how do they all work together? So basically, the idea is that with the digital transformation project, it's all about, in most cases, it's all about creating those new services and APIs in a way that enables you to kind of mix and match and create new flows that serve the new ways of dealing with digital channels and producing digital projects. So digital transformation are very much about, moving to the cloud, moving to APIs, and moving to microservices. That's just the landscape today. Technologies might change, but that's what most people do today. But the core principle of what we're talking about here applies to multiple technologies. And the idea is that, of course, you start with a legacy because, this is a digital transformation. It's not something that was born digital. It's a digital transformation. So you're transforming for something, and that something is your legacy. You're starting with a legacy. You automatically generate code that deals with those types of functionalities on the legacy in a discrete way. Those types of functionalities, or the way we call them, the SDKs, or these are the Java POJOs, are basically just standard Java code, which is an extremely important concept because you don't want to have the dependency on, legacy skills. You want the people dealing with those types of objects, you want them to have just, normal standard Java skills. So you create those objects, and then you create the APIs and microservices around them. So the microservices look like any other normal microservice that you would otherwise develop on your own. Only their data store part, the last part, is actually accessing the legacy system versus having an internal data store. Those APIs are, again, automatically generated, but they are just standard APIs. Then they can be deployed anywhere. Deployed anywhere means that they can be deployed on-prem, on the cloud, Kubernetes, Docker, OpenShift. It should be agnostic because you want to keep yourself all of these options available to you. And once you deploy them, of course, you do that through DevOps standards. Everything is automatically deployed. And of course, at that point, you can iterate on them because the entire process was automated and the entire process took you, very little time. You can now iterate on them. And that's one of the key concepts here, is the ability to move really, really fast in an agile way. So you deploy something to production, you say, well, I have this API, you can use it now. But if a customer or an internal customer tells you, well, that's a great API, but I need another field, or I need it to behave in a certain way, your answer is not, okay, now you need to wait 3, 4, 6 months for that behavior to take place. I can do it for you in a day because I can test it automatically and I can deploy it automatically again for you in a very agile way. And that's how you go to solve one of the biggest challenges, which is getting the acceptance or actually people using your APIs versus just you producing APIs and nobody's using them. So this is what the process looks like from beginning to end. And again, it's not a multi-year process to get this thing working. Of course, once you have that process working from beginning to end, you can start with an MVP. An MVP can be something as small as a single application, and within a few months you can start deploying APIs very, very quickly, and then add on it and add until the entire organization basically moves to a new way of working. And it has the flexibility of accommodating multiple scenarios using templating and other things. So this is basically the process. But hearing about it, I guess, is it's great, but seeing it, I would say that would be even better. So with that in mind, I will move it over to George to showcase a demo of exactly how that process works with regards to creating a mainframe API from zero all the way to it running as an API. So George?
Thank you very much, Zeev. And just let me present here. Okay, showing my screen. Just want to make sure that you're looking my screen and that you can also see that I'm swapping to some other screens. Am I right?
Yep,
Yes,
that's right.
Perfect. Thank you. So I'm going to run for you a demo, which has basically 2 objectives. First is to build an API for you from scratch that is going to make a connection to a mainframe, and we're going to use a COBOL code to do that. But secondly, and maybe most important, is to align this, or to show you how aligned this OpenLegacy strategy is with the QuickStart process and the 5 ways that we are actually talking about. Because the most frequent issue that we face when we're trying to define a new API strategy is basically that we have limited resources. And in order to manage this, we're trying to use the tool in the fastest possible way and automate as much as possible, and also avoid having people involved in the process. The only skilled people that we need to build an API, and you will see that, is a medium experienced Java developer. And this developer would be able to actually create an MVP from scratch. And let's say Seth was talking about taking an application, but we can go even more granular in the MVP. In this case, let's say I want to work with some code that has to do with some credit cards information that I have on my mainframe. And this is typically what you would be seeing, COBOL code that you really, well, most of the Java developers, they will not exactly understand what's inside, okay? So what we provide is an IDE that is going to allow you to build an API by running just wizards. And I'm going to run 4 wizards for you to see how I'm building the API. So this is the IDE that we're using. And as I mentioned already, I'm going to be running wizard by wizard. You can see the first wizard is going to be the structure generation of the SDK. And I just need to click on the OpenLegacy libraries and generate the SDK, put a name to my SDK. And then from here, you can actually start using some of the ways that we're talking about. One is, for example, generating the JUnit tests for your SDK, or picking and choosing the connector that you want to use. That is going to also be very easy because everything is out of the box. The connectors, they're all included. So I can connect into my mainframe kicks. I have an error here. Sorry. Okay, I have the name and I have the platform that I'm going to use. Then I can click next, and this wizard is going to just ask me for some information here, which is the address, the IP address that I need to connect into my mainframe, and then just I reserve your map and reserve port, and this is the way I'm going to enter into the mainframe. Okay. When I click finish, this wizard is going to generate the full SDK structure, which is going to be already having the properties of the connection to enter into my mainframe. Okay. And as I mentioned, what we're going to do is we're going to use COBOL code that has some information about credit cards as for my demo purposes. So what I'm going to do is I'm going to bring this code here into my local environment, and I'm going to copy that code inside of my SDK. So my SDK has been created already. I can open it. You can see that it's a regular Java structure of a project. And here in the sample area, I'm going to copy my code that is coming from the mainframe. You can do it straight from the mainframe, but I'm doing it this way because in the interest of time, it's going to run faster if I do it locally. So I just right click, and then I run the second wizard, which is going to be generate the model. What this is going to do is basically generate a metadata model of what's inside of the code. Here I can also generate JUnit tests that are going to be, DevOps aligned, DevOps ready for you to put it into whatever CI/CD or GitHub strategy that you may already have. Okay, so with this, you're not only using an MVP, but also making sure that you're automating the tests process and also building a very fast and easy connector. So as I click OK, this is going to build the metadata. It's, as you can see, the IDE is already recognizing the code on the bottom left. But we also provided some views of the SDK. In this case, you can see the COM area has been already identified by the SDK. That there are some actions that you can take from here. You can even see the code, or you can even see what's inside of that COM area, because this has already been converted into understandable Java code. So the conversion of the format of the variables, it's already here, and then you need to only call these as Java variables. So with that, I already generated my SDK, and what I need to do right now is just generate the API and the contract of that API. Okay, so just click on the wizard, generate the API. I'm going to call this webinar API. And from here, deployment starts to play a very important role here, because I can deploy as a microservices from here. If I choose microservice, I can pick some different platforms to deploy, and I can also use templating in order to comply with some, regulatory rules, or maybe some standards for coding, or some standards for security. So that's another thing that I can do at the SDK level and also at the API level. I can also play with caching. Okay, caching is another important tool that is going to help you to improve the performance and to make sure that the strategy of your QuickStart is going to be quick enough to respond to others without actually affecting the backends that much. Okay, so I'm going to take this off right now. I'm just going to deploy locally and disable cache, and I'm going to click next. So what I'm going to do here is just put the SDK that I created as the input for my API, and that is going to be basically the dependency that I'm going to be using to generate the contract. Okay, and as you can see here, I just run the third wizard, and the fourth wizard is actually the contract generation. So if I go back to my IDE, you will see that my API is ready to. Oh, let me just first deploy my SDK, run it as a Maven install, just to make sure that this is a Java executable file that can be consumed by the API. And then when I build success, I'm going to be able to generate the contract. And to do that, I just right click on the API, do OpenLegacy generate API from SDK, and I can put a name to name my API. And then, as you can see here already in the API, I have the possibility to generate also a unit, but I just need to point and click the variables that I need to use. And a Java developer will easily understand that this is the customer ID and this is going to be my input, and that I can bring the entire COM area structure as my outputs, because that's what I need to bring as much information as possible from this credit card. But you can play here with different variables. I can just bring some part of this or everything depending on whatever I want. So this is showing you how we're very easily defining contracts and very easily deploying on different formats. Okay, so as I click OK, this is going to generate basically my contract, and in a matter of minutes I just created an API that is fully executable. And to execute the API, I just right click on the API and click on run application, and this is going to launch the API, and it's going to take control of my port 8080. And I want to go back a little bit to this diagram because the deployment is also very important. In this demo, I'm just going to deploy in a Swagger spec mode, and you will see that running. But you notice that I am able to deploy in a microservice, or I'm able to deploy also to an API gateway. There's many formats that I can deploy on. So depending on whatever strategy you already have for your digital transformation, if you're using a services mesh, if you're using an API gateway, if you're using whatever tool you need, or the couple methods like SQS or Kafka or Cloud, we can deploy in that and make automation deployments as well through the templating. So templating is going to be also very powerful for you to make sure that you're deploying every time the same way, and that's one of the benefits of the automation. Okay. So this API is going to take control of my port 8080 in just a minute. And when that is done, it's here. And then I'm going to be able to open a browser and show you my API running on my localhost port 8080. And by default, we have the O2 security standard here on our APIs. You can take that off and use another if you want. But I need to authorize the access to this API right now. And from here, I can try it out. And just as you remember, there's some code in here. I open it for you just to see that there's some variables that I'm moving. And if I use this as the input, you will see that I'm going to get just one credit card data back. So I'm going to copy here that string of data and execute it. And you'll see that I'm hitting the mainframe and getting the information. How can I make sure that I'm hitting the mainframe? Well, I have here open for you a Kix session that is showing you that every time I run this code, it has a count on the number of times that I've executed. Right now it's on 411, and as I click, it's going to be 412. And also, another way to make sure that I'm hitting the mainframe is if I change this to, let's say, a 6, it's going to bring me other kind of data, and you can see that this is working. So with this, I just showed you not only how to build an API from scratch in minutes, but also how the OpenLegacy strategy is very well aligned with these 5 ways to QuickStart. By starting with limited resources, just one Java developer is good enough. An MVP, you just notice that just working with a single COBOL program is more than enough. Build a direct connection to a legacy system, we just did it. Automating the test process, you saw that we can generate JUnits pretty much at every level. And then simplify the deployment, you can automate the way you're gonna deploy into pretty much any platform. So with that, I'm taking this to you back, Marty.
Marty, you're on, yeah, mute.
Sorry, Yep, I muted there because it was longer. And then, so thank you very much for a great demo, George. I guess the next question we're going to bring up is getting steered in the right direction with these offers. We can really give you a personalized demo very easily, and there's an easy link you can click to actually get to that when, if you go and grab these slides afterwards, or even we can schedule a proof of concept with you. And we'd love to do it on site, be able to work with you and show you how this really works. Because the proof, nobody believes it until they actually see it on their legacy system, and we're happy to do that for you. So the whole idea here, this picture is kind of a funny one, the Digital Transformation Steering Committee, then it's agreed we remove the word steering. Sometimes that's how it feels like when you're trying to do digital transformation. But we want to make sure you're actually doing it and it works well. So now we're going to go to Q&A, and we just want to leave these up here so you can think of the 5 steps that we discussed.
Awesome, awesome, awesome. Well, we do have plenty of time for questions during the question and answer period. So if you have a question, please go ahead and use your GoToWebinar control panel and submit it, and we'll go ahead and dive right on in to the questions that we have so far. So the first one is, how would you approach left to right testing?
Zeev, do you want to take that one?
Yeah, so I'm guessing that by left to right testing, what you mean is testing from what I would call top-down testing. And if that's not what the what the question means, then I apologize. But assuming that what we mean, basically top-down testing means that you test the you test it from the end result, meaning from in a front end, for example, you test it from the user experience, and for a CLI, you test it from the usage of the CLI, but basically you test it from the end result, the end point. And what I would say is that doing it this way makes a lot of sense, because at the end of the day, what you want to see is that the user experience is what you want it to be. And there are a lot of tools and a lot of different frameworks around that. For testing front ends that are web-based, front ends that are mobile-based, and all of those things. That will, get you to a point, but that doesn't get you all the way, of course, because, for example, if behavior is not exactly what you expected, or if behavior is as you expected, but performance and latency are not what you expected, then you have to move further down to the bottom and figure out what went wrong. One of the key challenges in doing that is that if you have a lot of moving parts, if you have middlewares and stuff like that, then that's just the reality of it. You have a lot of finger pointing, because the legacy team will say, we don't know what you're talking about. We have a transaction running in less than 10 milliseconds, so it can be us. The integration team would say, well, the workflow is working, and the front end team would say, well, the front end, no problem there. And so it will be hard for you to understand exactly where the problem occurred. Versus having a simplified stack, which is what we're suggesting, that basically it's not only simplified, but because everything is code-based, all the tracing and all the records are kept in a way that's standard. So you can put it in Splunk, you can put it in any kind of other analytics tool that will tell you, well, it spent this amount of time on the front end, this amount of time on the back end, this amount of time in the middleware. It broke down here because the response here was not the response that was expected. So what I would say is that testing is a holistic kind of a view, and you need the same stack across, or at least you need the stack to talk in the same way across the entire journey. And by standardizing and by simplifying the stack on which it runs, really goes a long way into helping you standardize the testing facilities and the tracing facilities, so that you have one holistic view of everything, and you're able to basically understand exactly, if something went wrong, where did it go wrong, and things like that. So I would not necessarily think about it as if you go top down or bottom up. I would think about it as just having a certain a standardized way of thinking about that holistically, so you can see the entire picture when testing. And I hope that answered the question. I'm not sure if that was the meaning, but that's if that's what you meant by that, then that's my answer.
Okay. All right, great. Next question here. Let's see. You said legacy people aren't required. So what attributes of people would make up good team members?
So I think first of all, let's kind of be. We're not saying legacy people are not required. We're not here to retire anybody. Legacy people do have a very important work in keeping the legacy system up and running, of course. What they're not, what's not required is the close interactions between the legacy side and the digital side, and that's the important thing. Abstracting between the two platforms means that on the digital side, on the side that really you wanted to move quicker and to be focused on delivering the best user interface or the user experience rather, on that side, basically what you would need is just standard Java skills. Our implementers need 2 years of experience in any kind of standard Java stack, which is a rather common skill set. Of course, from the front end, you need front end people. But that's basically the skill set. It's very much available. There's nothing very specific. You don't need to be an architect. We have a great example of because we've been in the industry for some time, and we've revisited customers in different steps in our careers. We do have examples of customers where we were there doing projects before, and what used to take 8 architects, all with deep legacy knowledge and all of those kind of things. Now, with OpenLegacy, we can do the same thing with just a single implementer that had 2 years of experience in Java. So that really kind of paints the picture of how much things have changed.
I think the only other thing I'd add to that kind of quickly is one of the big advantages here is you're already writing integration, let's say, between 2 cloud systems and non-legacy systems. As it is, you can use those same people generally this is just another project for them, and they can just use our tool to basically generate a Java application, which then they bundle in the same way they always do with microservices and connections. So it's not just the fact that you don't need certain things, but also the fact that you're using the common skill sets that are usually in the integration teams already, and that's a big advantage.
Okay. Great. Plenty of time, guys. If you have a question, go ahead and use your GoToWebinar control panel and submit it. Our next question here, the Ayalan, and sorry if I mispronounced that slide, didn't have API management listed. Is there a way to do that?
Yeah, absolutely. Oh, you want to?
Mm-hmm.
Okay, so absolutely. I mean, API management was not listed there just because of the fact that it's not part of the API generation process. But of course, on top of that, you have API management. The way to think about this approach, I mean, an API management tool would need APIs to manage, right? And there are a lot of different options out there. Actually, we do, have some relationship with some of those vendors, and they can help you govern and manage and deal with things like high availability and security on those kind of on the APIs, but they need to be fed. You need to create the APIs for them to manage. And really what we're talking about here is that component or that part of that, which is creating the APIs for them to manage. But definitely on top of that, you would need some kind of an API management, more elaborate or a more simplified solution for that. But you would need an API management component on top of that.
And I'll say also that the ICP is the IBM cloud. Sometimes the cloud companies actually have some API management that plugs into what they do. So it may just not be, it may be implied. Plus Kubernetes takes care of some of the orchestration that some of the API management does. So I mean, I agree completely that people use API management with our stuff all the time, and there are different options there to do.
Okay, great. Next question. Let's see. What are some examples that show how quickly you can build connections to legacy systems?
So I think a good example would be a major telco in the Americas. Basically, they were struggling with all different types of technologies, and this is a tuxedo-based system in this case. And they were struggling with all kinds of different ways of connecting, and it took them time. Basically, we were able to provide 6 working APIs in 3 hours. after an initial setup of a day, just getting there, setting everything up. So 6 APIs in 3 hours. I think that's pretty fast. And these are production ready APIs. So they were not deployed to production, they were deployed to a production staging area. But I think that's pretty fast. Now, granted, these were relatively simple APIs, meaning not a lot of additional business logic that needed to be added. But once you go there, once you're able to deploy that fast, that really opens up a lot of opportunities and ways of thinking that were not possible before. Just in terms of if you're able to put out there in the market a completely new product within a week or two, that really can change the way you think about your strategy. Why not experiment? Why not create products that you're not sure are going to be a success because now it costs you very little time and effort? So that really is a game changer in terms of how it enables you on the business side to do things. But in terms of how fast it is, so these are a couple of examples. So 6 APIs in 3 hours, or to give you a full-grown mature implementation for a very, very large bank, and they're able to deploy around a dozen APIs per week, which is I can't even tell you how much of a game changer that is for them, because they were not used to doing anything in a time frame of a week. They weren't used to doing anything in the time frame of a month, and all of a sudden they're able to deploy a dozen per week. So these are kind of it's not just an improvement. It really is game changing, and you're basically limited by demand, not by supply. And that opens up an interesting ways of thinking about the business and thinking about the IT component of the business and what it can do to help the business.
Excellent. Okay. Great question here. Next question. Can you explain how OpenLegacy would work with MuleSoft or Apigee?
Sure. And so we actually do have a relationship with both. And the way it would work, for example, with Apigee, that's very simple. We produce the APIs, Apigee manage the APIs, so we register the APIs to Apigee. It can be an automated process, and so they will be then from that point on they will be managed by Apigee. For MuleSoft has two components. They have a API management component and a ESB component, or orchestration component. And basically you can use either the same way you use Apigee, or you can actually deploy the OpenLegacy components as nodes within MuleSoft, so then you can further orchestrate them inside the MuleSoft IDE. So there's this integration, for lack of a better word, between the OpenLegacy platform and the MuleSoft IDE to enable you to basically grab those components, and then you compose them very easily as just nodes on MuleSoft, and then you can leverage the entire MuleSoft platform with all of the strengths and capabilities.
And by the way, we have a couple web pages on our actual website that describe specifically Apigee and MuleSoft. They're under the solutions area, and they basically go down, and there's one specifically for MuleSoft and one specifically for Apigee we just created, and those have solution briefs. They have specific demos in our demo center that are specifically designed to show these, and we also have technical data sheets that go through this process. So we have a number of good artifacts. They're all linked to from those specific pages on our website.
Awesome. All right, great. So we're about 7 minutes to the top of the hour. We have time for a few more questions here. Next one, you talked about testing. Do you also help with security?
Yeah, definitely. So it's important to know, I mean, we're not a security product. Our main reason for being is not security, but we are an integration product, and we are a code generating product, and that gives us a lot of opportunities to improve at least our small part of the chain in terms of security. And the way we do it is, I would say, threefold. So first of all, just by the nature of the architecture, if you think about, and a lot of organizations are moving from XML to JSON, moving from XML to JSON can be a little problematic on the security side, because you're moving from a very strict, kind of a almost trunk typed protocol into basically JSON that has numbers and strings. And that can leave a lot of vulnerabilities. Now, the traditional way of dealing with that is adding a runtime element of validating the JSON, but that's a runtime component, and things can go wrong. With OpenLegacy, if you consider the approach, basically you have a Java component or a Java SDK that is strong type, and that really fortifies that protocol. So that's just one example, like the very nature of the architecture, how it adds to security. But more importantly, I would say, if you talk with a lot of kind of cyber experts, they will tell you that, there are a lot of products out there that, do all kinds of specific things, and they're very, very good at it. But one of the key vulnerabilities that people have is, human errors. People write code. Code can be, people make mistakes. Code can be vulnerable, and you can introduce a lot of vulnerabilities this way. And of course, there are a lot of ways of a lot of products out there to do to validate and test and see that there's nothing wrong. But what can be more robust than automatically generating the code to begin with, with all the best practices and standards that you wanted to include? And that is something that we can provide, because everything is co-generated and based on templates. You just introduce the specific standards that you want to introduce, and they're already baked into each and every API that you're creating. So again, not a security product, but we do adhere, of course, to all this, security. We work with very large banks and regulated industries, so we do adhere to all the security standards, but also we add some components or some elements of security that you would not necessarily otherwise have with other integration stacks.
Also, our code is just so much simpler. It's a direct connection to the legacy system instead of going through a bunch of middleware that potentially is just opens you up. The complexity of some of these other systems makes it actually harder to debug everything, and you could have a security hole in one of those things. And that's another key part of that, is just the simplification that we're actually using and the modern technologies we're using. New versions of Spring Boot and things like that. These are ones that have been designed with security in mind for the web and cloud type systems.
All right, great. So we're 4 minutes to the top of the hour. I think we have time for one more question here, and this should be an easy one for you guys. How do I schedule a customized demo for my team?
Well, I mean, generally, you can go to our website and go to openlegacy.com DevOps demo, or go to openlegacy.com DevOps POC and actually register there. You obviously can also just go to our website and just submit a question and make a request.
All right, great. Well, we got about 3 minutes left, so I'm going to go ahead and close out the question and answer period of today's webinar. Do want to thank everybody who did submit questions. There were some really good ones in there, so thanks a bunch. Also want to remind the audience that today's event has been recorded, so if you missed any or all of the event, or if you just want to watch it again, you will have the opportunity to do so. Following today's event, a little bit later on today, we will be sending out an email that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. And while you're there, please take a look at some of the other webinars that we have upcoming and on demand. Hopefully there'll be one or two at least that pique your interest. And then also, before we close things out and I say my final thank yous, I do want to get to our AWS, or not our AWS, our Amazon gift cards, $50 Amazon gift cards. We have 3 of them to give away. So without further ado, we'll go ahead and make our drawing here, do our drawing for 3 winners. Our first winner is Richard Klein. Congratulations, Richard. Our second winner is Matt Collins. Congratulations, Matt. And our final winner today is Bruce White. Congratulations, Bruce. All right, great. Well, it just leaves me to say thank you very much to Marty, Zeev, and George for a great presentation today. Lots of good stuff. So thanks for your time, gentlemen. Really appreciate it.
Thank you to everyone.
Thanks, everybody.
Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody.